accept that. Secondly, just because what I'm showing you is one way doesn't mean it's the only way to design a car. That's it's the way I've learned it, and it's the way I do it, so it's the way I'm going to show it. Obviously, road cars and race cars have very, very different priorities. The process you use to design the car is fairly similar. There are some differences because things like safety, there are certain DOT and NHTSA regulations you have to meet for a production car. Race cars, you have certain crash criteria, which may or may not be defined by the sanctioning body being the people who put on the races, run the races. So there's a variety of difference there, but as like I said, the basic process is the same. One big thing to point out is, particularly with road cars, car design is a very collaborative process. No one person, outside of some very simple limited volume race cars or road cars, can design the car in totality. You can come close, but it's not a very good way to do it because it takes forever and a day, and you are obviously not taking into account or taking advantage of the expertise and knowledge and insight of a lot of other people. So it's important to realize that even though I'm talking about it first person singular here, understand many people would be involved in this in a typical process like this. So we can go to the next slide. Okay, why me? Why am I giving this talk, right? Why aren't one of you people giving this talk? Reason why, other than being asked by Elizabeth, which is the main reason, is I've been designing road and race cars now for onwards of 30 years. I have what I would call a reasonable level of success in this area. Examples being on the race cars. Cars I've designed or worked on very heavily have won Le Mans overall twice. I won the Le Mans GTE category with my car, that be the new generation Ford GT. I've won the Indy 500 with the car when I was a technical director for another manufacturer. Same thing with 24 Hours of Daytona, 12 Hours of Sebring, Petit Le Mans, a bunch of other ones. You know, you can go on and on, but it gets kind of boring after a while. But I've got some experience with race cars. Also had some bad race cars. I will admit that too. You know, everybody does. On the road car front, fundamentally, four cars that I've been very heavily involved with. The Ford GT, the new generation Ford GT, is really my car. I was the chief designer in that program for Multimatic in Canada, who is the manufacturer of the car for Ford of Dearborn. So it's a bit of a confusing situation there. The Roof CTR3 is a variation on a Porsche. There's a gentleman in Germany by the name of Allos Roof, who for many years has been doing very sophisticated, very advanced modifications on Porsche 911s. The CTR3 is one of them. Aston Martin 177 is, or was, the top highline car for Aston Martin. Still is, actually. It's they built 77 of them, and they sold them for somewhere between 2 and 3 million pounds a piece, I think. Other thing to point out, though, on the road cars is I am not a stylist. I don't do the exterior styling or look at the car. Other people do that, which makes me very happy because I'm not very good at all on that. I'd like to be. I'd like to be able to do more styling, but you know, everyone has to know their limitations. And mine right now is I'm not a great stylist, so I don't go there. Next slide. Just some pictures of some race cars that I've done. BMW on the upper left. The Audi's third one over on the top row. Toyota, showing mostly sports prototypes, long distance endurance racing, and then GT cars. You can see a Panoz Esperani there and a Ford Mustang. That kind of gives you an idea of sort of some of the cars I've designed over a number of years. Okay, next slide. These are the production cars I've done. You'll see there the roof CTR3, Aston Martin 177, and off on the right is the Ford GT. Um, the the number 3 and number 2 on the roof CTR3 and the Aston Martin 177, that image is out of Evo magazine, which is a European, it's the UK car enthusiast magazine, and every year they do car of the year and hypercar of the year. And you can see in this particular year, my cars came in third place and second place. The first place car was the Bugatti Veyron, which would have been nice to have that under my belt too, but that didn't happen. But anyway, that's sort of an example of production cars that I've done. Okay, that gives you a little idea who I am, what I am, why I'm giving this chat. So if you go to the next slide, for this presentation, I've decided to use a concept car that I've been working on for many years. The reason for this is, even though I'd love to give a talk on the Ford GT or the Aston Martin, the problem is the OEMs, they don't like it when I talk about cars I've designed for or with them. They typically like owning or controlling the images and info about the car, even when the car is no longer in production. As it's their car and they paid me, I try to respect their wishes. Plus, they have a lot more lawyers than I do, so I have to be careful there. I remember talking to the CEO of Aston Martin after the car, a couple months after the car came out, and I was getting interviewed by a couple of the car magazines, and he came up to me and suggested that I probably refrain from doing any of those because Aston Martin would have a difficult time explaining to their customers why the most expensive car Aston Martin has and sells was basically designed by a redneck from Georgia. They thought that would be something that their customers would have a real tough time understanding, particularly when they're spending £3 million on the car. So unfortunately, as much as I like to do that, I also like not being sued. So we're going to go with my concept car. The other advantage that has, it's not a bad story from initial concept to detailed design, with most of the necessary steps, in there, save some DOT crash steps, but I include some of that in the talk, even though it's not related to my car. So hopefully it won't be too bad. Hopefully people won't be too bored by it, but let's get on with it. So how do you design a car? So next step is, next slide. Okay, I call it Project Escape. So what is the initial design process that I go through? Well, some of this sounds real obvious, and it is real obvious, but a lot of times the things that are most obvious are the things that people miss because it is something that, well, we should know that. So the very first thing is, what do you want to do? What's the initial concept? What is the thoughts of the program, the car? What are your dreams? Or if it's a manufacturer, what are their dreams? What are their thoughts? Right? You need to know what they want or what you want. What is the end goal? What is the package you're trying to produce, and to whom and why? And don't just think about these things, write them down and continually write them down through the entire design process. I have a little book for every car I've designed, and in there goes all my thoughts as I'm going along night, day, day, literally on the bathroom, in the tub, wherever, out, out on a date. Quite literally, I've done this where I have a thought, I stop the date, I pull out my book, and I write a little note in there and put it back. Date wants to know what the hell's going on. I tell her, and that's probably the last time she dates me, but anyway, it gets me through the program. So what is the goal of the program, right? That's really critical. What is the timeline to do the program? That will control what you do. If you only have a couple weeks to do it, you're not going to do very well, right? And you're not going to do very sophisticated design. If you have 10 years, well, you can optimize it all you want. It'll be obsolete by the time you get it out, but the timeline will really, really help control what it is you do. So pay real attention to that. Also, got to pay attention to the resources you can put in the program. And that depends whether it's for an OEM or a small scale program, just what resources. And by that, I mean, not just people, not just engineers that you can have do X, Y, and Z, analysts do this, managers do that, but also the hardware and software you have in front of you. You know, do you have enough CAD and CAE software to do a complete developed car design, or, you know, are you limited? Again, that will constrain you in a way that allow, and it's a good constraint. None of these things are bad. All these things I actually find very good, because in the end, it puts book stops on the car. It tells you what you can and can't do. It constrains you to what is realistic in the time and resources you got. And if you don't do that up front, the car will be a failure. I don't care who you are. I don't care what OEM you are. It will not work. Other things, you know, if you know it, what's the anticipated sales price of the car? What is the anticipated production of the car? That's also really, really critical. That may be the critical question to answer. That may be the single most important initial question there is. The reason for that is the volume of the car, the production volume of the car, more than anything else I can think of, controls the design of the car. If you're designing 800 Ford F-150s a day, how you go about designing that car, how you go about making sure it assembles correctly, and everything about it is completely different if I'm doing 2 or 3 cars for the 24 Hours of Le Mans for Audi or BMW. Completely different way approach, completely, and everything you do is different based on that volume. So that's something I really believe is important to start with, is understanding all these things. You need to know all these things. I guess that's the point. So once you have all this down, write yourself a basic spec for the car. The more detailed, the better. But if you don't have a lot of detail, write down anything. And, you know, people go, what do you mean by a spec of the car? Well, okay, the car's going to have 4 wheels and tires. That may seem like an obvious thing, but if you write it down, you know it's the obvious thing. You know, it's going to be a convertible or a hardtop, 2-seater, 4-seater. All these things you need to really define up front. And if you go to the next slide, you'll see what I'm talking about. Um, all right, before we go there, this is good. The initial concepts and thoughts, what I call the dreams. You know, what is it you want to design, make? What is the type of vehicle, looks, performance, features, and who is your customer? These are all things that you ought to be thinking about in your head initially. These are your dreams if it's your own car. And if it's the manufacturer's car, you want their dreams. You want to understand what all those are. Oftentimes you can influence the OEM as you're designing the car, even before you design the car, by pointing them different directions. I have actually found the OEMs are very, very open to that. Surprisingly open to my crazy ideas, my crazy thoughts up front, telling them, take a look at this, take a look at that. I've actually never had anybody in any OEM go, nope, forget it, we're going to do it my way, and that's it. So it helps you if you can come up with a vision in your head of all this stuff and relay that either verbally or graphically to your team, your design team, the OEMs, or even to yourself. And we'll get into that in a second. So go to the next slide. All right, this is a little blurb about the importance of manufacturing volume for the car. As I said, more than any other parameter, the production volume will dictate and control the method of manufacturing of the car. So the manufacturing method will there control overall design, cost, general characteristics of the car. Will control most everything on the car. And what you have now is a situation where the higher the volume, the lower the unit cost, the lower the part cost. The higher volume then means I have more freedom in tooling design and amount of bespoke tooling and parts I can make on the car. If I have a very low volume, I can't really afford to spend a lot of money on tooling. I'm making special, unique parts for the car. I have to grab a lot of parts out of what we call the OEM parts bins. There are sweet spots and bad spots in this volume manufacturing process. The toughest spot, ironically, is what I call the medium volume range. 500, 1,000, maybe 2,500 cars per year. This is a really, really tough spot to work in because you've got enough volume that you need to make decent tooling, and you have enough volume that people are going to expect specialized bespoke parts in the car, but you don't have the volume to really pay for that. So it really, really becomes a difficult spot in that particular area. Other thing to note is tooling costs still dominate most program costs. Proper tooling, but tough to amortize it unless you're selling a lot of cars. Other thing is you have to really get a handle on the manufacturing process, build line, design, parts delivery. Is it JIT, just in time or not? All that is part and parcel of this volume production. If you're doing really, really high volume, you can have just in time, and how you do the parts delivery is very different if you're doing a very low volume, 1 or 2 off car. So very low volume cars can generally go one of 2 ways. You can have a lower cost product, minimize the special tooling, lots of robbing the spare parts box from other manufacturers, other OEMs, limited engineering effort. The Panoz Esperani would be an example of this. Now, understand when I say lower cost product, I'm talking about the cost to design, manufacture the car. The sales price of the car isn't necessarily going to be particularly low. I mean, a Panoz Esperani was $120,000 to $220,000 a piece. So that's not exactly low cost, but in terms of the manufacturing of a car, design of a car, that's a low cost product for a low volume manufacturer. The other way to go about it is have a very, very high cost product, like the Bugatti Veyron or the Aston Martin 177, because you can do the proper tooling, specialized parts, electronics, engine. I mean, the engine in the Aston Martin was special from Cosworth. Bugatti Veyron made their own engine, whereas the Panoz Esperani was using, a Ford V8 out of the Mustang. So huge difference in cost there, because huge difference in the price of the car, and huge, even though the volumes of the car might be very, very similar. So anyway, that's just a spiel about how manufacturing impacts the design of the car. Go to the next slide.
Give me 1 second. We've got someone in the waiting room.
Yeah, no problem.
Oh, they disappeared.
All right, this is my, for my car, what I call Project Escape, was my original vehicle spec. There's actually 3 or 4 pages here. We won't go all over them, but I want to highlight a few things to show you, what I put in there. Cost is a big factor. That's probably the #1 factor, which is why it's on top of the list. Low mass. What's the mass of the car? I want a very, very light car. I want a very simple, low-cost chassis. No amenities, no doors, no roof, no adjustable seats. General footprint no bigger than a Lotus Elise. It's motorcycle powered. Chain drive to diff. Need a reverse mechanism that works. So these are all the things that I want in the car. Next page will show, it just continues this the spec sheet. But if we go to the next page, more of it. As you can see, there's, I get fairly specific in what I want in the car up front. I want separate roll hoops behind each driver. I want no luggage, no in-car luggage space at all in there. I want the engine drivetrain to be visible from top and rear. I want the tire sizes to be so-and-so. I want the fuel capacity to be around 10 gallons. I want the wheelbase to be around this area. I want push rod suspension here and there. I want to be able to put a trailer on this thing. So, as I said, I get fairly detailed in what I want. Look at running exhaust over top of engine. The more detailed you can be, the more specific you can be at this stage, the better it is overall, because you'll know what you're trying to achieve and you won't be guessing down the road. So next slide. I think the next slide is maybe the last on the, okay. Yeah, talks about the trailer, reason for the trailer. I won't go in that right now. We can talk about that later. Um, I want bodywork at a fiberglass or SMC, sheet mold compound, plastic panels. I want an adjustable paddle pack. I want adjustable steering wheel. And I want to make this as a kit car, component car. No attempt at making this thing street legal as a manufacturer. So that's sort of my spec. But at the same time, I start writing down some of the issues I've got right up front that I want to deal with. Um, some of the things that maybe I don't really have a good answer for at this stage in time, but things that I need to think about and things that are variables and options in the car that will be very relevant to the overall design of the car. But at this stage, I can't answer those questions. Perfect example is chassis design. I have 3 or 4 concepts. I'm not sure which one is best or cheapest, but always ready to look at other designs. Same thing on the suspension corners. I would prefer to buy a production car package, the upright hub, brake package, as a minimum. Suspension arms I can make pretty cheaply, but if I can use some production car bits, then all the better. So, okay, what options do I have there? Mazda Miata, okay, I'm not overly impressed for those bits for my car. Probably won't want to do that. Corvette bits, way too expensive for my car. So, okay, I don't have an answer for that, but I know I don't have an answer. I know I have to find an answer for the suspension. I know I have to find an answer for the chassis. Same thing on steering rack. I need to find an answer for the steering rack. And finally, body shape. Like I said, I'm not a stylist, so I have concepts in my head, and the concept is a derivative of a Hot Wheels car. Really, that's where it started from. This whole concept, like I said, dreams, it's really, really important to understand what you want and what your dreams are. The start of this whole program 10 years ago with me was when I bought a specific Hot Wheels car, and I said it'd be really cool to turn that thing into a real car in some manner or form. So the ideas can come from anywhere. It doesn't matter. You just have to be energized about it, and you have to be, wanting to go that direction. Next slide. All right. This on the left, 2 shots are of the Hot Wheels car. I've torn it apart. I took the wheels off because I did a little laser scan on the thing to start with. So that was the basic start on the car, was again this, like I said, this stupid Hot Wheels car. To the right, you'll see a picture of a concept car called the Maserati Birdcage, which I also like. And if you look at the side views of the 2 cars and you squint real lot, you can kind of see how there's a general design style of those 2 cars that are similar. The design style is that there are very definitive fender sections, front and rear, where the bodywork between the fenders gets very, very narrow. There's a big undercut on both of them. And they have a very sloping, long greenhouse, very big greenhouse, actually. In both these cases, they're hard tops. I would do a customer car. You can admit, Paul. Um, So anyway, just gives you an example. In this particular case, you think, well, how crazy is it to pick a Hot Wheels car and use that as the basis for your design? But why not? I mean, there's nothing that stops you from doing the things the way you want and picking whatever inspiration you want from wherever. Um, if your inspiration is a flower in the field, then go for it. Use that as the inspiration for your design. Don't feel like you're constrained to, you know, production cars because that's what people have done in the past or this or that. Be able to think beyond that scope. It's if it's something you're doing on your own or like, you have complete freedom in that area, and that's kind of why I like all this stuff. All right, next slide. These are some Okay, so as I said, I've got a spec sheet, and on that spec sheet are all the things I want in the car. Then I have things that are issues that I don't have answers for, like, suspension, like tires or wheel sizes or something like that. I also have in the same sort of document, again, I put this all in a book, a binder, is other things to consider in the design, things that I haven't, not necessarily what I'm going to do, because I know I need these things, but how I'm going to do them. Things like, where do I put my radiators? Where do I have the rad exits? How do I route the water and oil lines front to back? Um, do I have a tilting windscreen? Where do I put the bodywork splits and mounts? Do I have a push-pull cable shifter with the paddle option? How do I make seat cushions? How do I make step over easy? Because there's no doors on this car. It's what we call a step over car. You step over the body to get into it. Um, how do you make the pedal package adjustable? Let's admit David. All right, continuing on, it's things like, all right, how do I do side protection for the center of the tub? Where do I put the fuel cell? How wide a seat? How to attach head roll bar over rear tubes? How to do the front roll hoop design? These are all areas that are design criteria, not design criteria. These are design exercises that you need to come up with answers for. But if you don't know what it is you need to put in the car, besides the more obvious things like engine and passenger and driver and steering wheel, you'll forget about these things. So I tend to write them out, and I continually go back to this document and pour over it again just to make sure I don't forget anything as I'm working on the design or analysis of the car. So a lot of steps up front, even before I start sketching or drawing anything. And that's something to emphasize again, is there is a lot of homework that you should do up front before you start sketching. Or you can sketch anytime you want. Like I said, you can do dreams, you can do that now, then, whatever you want. But in parallel with that, you ought to be doing this kind of work, because this will give you the document that you use to flesh out the car, or it's the document I use to flesh out my car. Next slide. Okay, so now what do we do? Well, like I said, dreams, concepts. I'm not a very good stylist, but I give it my best shot. So what I do is I come up with some initial shape concepts. At this stage, I'm not worried about, does the driver or passenger fit in there? What size tires and wheels have I got? What size motor have I got? Is the proportions all wrong? Are my tires and wheels way, way too big? If you look at the left-hand side drawings, the very bottom, you'll notice it's got, 24-inch wheels with, 5 series tires on them, right? That's a typical stylist cheat. We all like to make world's biggest tires or biggest wheels and thinnest tires because it looks really good, but there's no way that's ever going to work on the car. But so at this stage, you don't really worry, at least I don't really worry too much about that. I'm trying to generate styling concepts. Are there particular areas, particular shapes that invoke some emotional response from me that I want to retain as the design is evolving? And if you look in the upper left-hand shot, that's an interior thing. And in this case, you can see there's no seats in there. It's basically 2 pockets in the bodywork, one for the driver, one for the passenger. There's like a big center section in between it. So, but again, it's all sort of organic. That's probably the best word to use here. It's just a very organic design. It's not separate components like you would see in a typical production car. So I like that idea. I like having it all sort of one mass that grows from a start, instead of having separate seats, separate dashboards, separate console. That's an idea I like. So that's one of the areas I'm pushing on. We go to the next page, you'll see some more designs. All right, this is a really first shot on CAD. And again, I will be the first to admit this is ugly as can be. I don't care. The tires and wheels aren't the right size. But I got a driver in there, I got a passenger, I got something that looks like an engine in those four tubes on the top. Well, that's the exhaust, because remember I said I want the exhaust to stick over the top of the engine and exhaust on top of the bodywork. Well, again, all this is doing is taking some of those concepts and dreams I had and trying to coalesce them into something that is graphical that I can, work with and play with. So if you go to the next slide, okay, this is a bit more refined. This was done off of something called Blender, which is just a graphics package. But as you can see here, still got my two seats in there, sort of um, maybe not as organic as I originally thought, but seat shell in there and somewhat body work. You can see it's in this case I've got the what would be in effect the hard luggage side panels physically attached to the car. So this doesn't have quite the wasting I wanted, but it's getting shape-wise closer to what I like. Again, it's just an iteration process. I don't know, how does somebody go about doing this? What is the process where I do this iteration? I don't know. It's the artistic side of you coming up with this. There's no real procedure I can tell you people of doing this. It's just sitting down and sketching and drawing and doing all that kind of stuff and doing it over and over and over and over and over until you refine it to the point you like it, or give up on it and have a professional stylist do it. That's the two options. So if we go to the next slide, the other thing I do is, even though I've designed the shape here, at the same time, I also act like the customer. And what I do is I literally email to myself these images and ask myself to critique these images. You go, well, that's insane. You're the guy who did them. How can you critique them? Because I'm putting a different hat on now. I'm putting the hat of a customer, and I'm saying, well, what do I like and what do I don't like about this car? And that's everything in red there. Elizabeth, I don't know if you can, if you can expand one of these blue images. You should be able to. Up, go back. Just double click on it and like, oh, maybe
No, it
not.
doesn't.
All right, never mind. All that's on there are criteria that criticisms I'm making about my own design, which again seems sort of like that can't work, but it actually works quite well because you are able to separate yourself, or should be able to separate yourself as the designer from the critic, from the consumer. That's also an important point when you're designing a car. You have to have that ability to swap hats, because this tells me what I like and I don't like about the car in a very clear-cut way. I mean, like, I can't ignore it when I send an email back to myself saying your design sucks here and there. But that's what I do. And I know a lot of designers who do that kind of thing. We'll let Ion in. All right, we'll go to the next slide. You'll see, okay, sort of evolving here, isn't it? These don't necessarily look too bad. It's two slightly different concepts. The one on the left has two separate fairings for passenger and driver, slightly different engine opening. The one on the right has one aero fairing over the passenger and driver seats, slightly different engine opening, and slightly different in the area behind the headrest. A couple other areas, different details, but as you can see here, either one of these, at least from my perspective, doesn't look too bad. So that's sort of where I left it in terms of the design process. I would still be evolving these, but this was sort of the last bit I did where I was starting to feel comfortable with the design. The one thing I never did was I never converted this to, so that's not exactly low cost. So if we go to the next slide, you'll see my really bad initial CAD development work. There you go. Again, this was actually done in parallel with my hand sketches, but again, done very, very early on. But if you look at it, you can see it's got seats for 2 people, engine in the rear. You can see the engine. It's got really, really way too big tires and wheels on there for proportionality. But again, you do that kind of stuff. Go to the next slide. You'll see side view and front view. And yeah, you can see, the tires don't fit the fenders. The fenders don't fit anything. But again, this gives you sort of conceptually an area to start with. So all this stuff you do sort of before, I don't call this designing the car. I call this concepting the shape and imagery of the car. So far, we actually haven't designed anything on the car, even though we spent a lot of time getting to this point. So if we go to the next slide. Okay. The other thing I do is I look at initial chassis concepts. Again, none of these things are necessarily designed specifically to fit the car in terms of passenger area, where the engine goes, or if the engine fits, or if the wheels fit, or any of that kind of stuff. It's pretty close. They're all generally pretty close, but this is more, again, conceptual. And it's how are you going to do the chassis? Well, I want a very low cost chassis. So that's steel tube frame. The one on the left is a bunch of rectangular tubes that are all welded together. The variation on the right basically takes the front clip and makes that an upper and lower tube that's just one piece computer bent piece of tubing. Same thing on the rear. So in that case, I'm saving on a lot of cutting and welding. I pay for it in terms of having to have CNC bent tubing, but nowadays that's a very inexpensive process to go through. So again, what I'm doing here is I'm just coming up with the general concept, but then applying manufacturing methods. Remember, we go back to manufacturing methods and talked about how important that is. Okay, here's a case of, well, there's a manufacturing method of being able to computer bend steel tubing really, really accurately nowadays that allows me to maybe do a little bit more sophisticated advanced chassis design than what I originally started out with. So that would be an option to look at. Go to the next stage. Next slide. A couple other ways of dealing with it. The one on the left is a bunch of steel tubes, but then sort of in transparent color there would be sheet metal sides, not necessarily all tube frame. Center section would be tube frame. The front and rear clips would be, in this case, aluminum honeycomb. That panels you cut, you bandsaw, and then you rivet them together with intermediate pieces of sheet aluminum. They're called cleats. You cleat the outside faces and the inside faces where any aluminum honeycomb comes together, and they rivet and bond them, and you create an aluminum honeycomb structure. That's a nice way to do it. You can buy the aluminum honeycomb very cheap, not cheaply, but you can buy it. You can get it water jet cut or bandsawed very inexpensively. The stuff sort of self-jigs together. You don't need a lot of tooling or jigging to assemble this chassis. And it's got really good crush resistance. If you get hit in the front or rear, the aluminum honeycomb absorbs a lot of energy. Problem is it's not easy to put point loads in aluminum honeycomb. Point loads being like the suspension arms. You need to have some sort of internal hard point in the aluminum honeycomb to take those distinct loads. So you have to design that in there now, and you have to add that componentry and that cost and that complexity. So, okay, again, these are just different options to look at. The one on the right-hand side is a bit bizarre looking. It's probably got too many stamped holes in it, but this design has a really, really simple center chassis. It's got a Z-frame, left and right, protect driver and passenger. It has a hollow aluminum tube, big diameter aluminum tube in the center that acts as the main torsional component of the car. That's also the fuel tank. Then up front is a bunch of sheet metal, and these are stamped sheet metal pieces. There's an outer and inner stamped sheet metal with a return flange on it, and you basically bring the two together and either spot weld or rivet together so you have a hollow box, and then you fill that hollow box with two-part expanding foam to give it some rigidity, and then to cut the weight on it and increase the sectional stiffness of the paneling, there's a bunch of flanged holes in there. So in this case, what I've done is I've done 4 different conceptual ideas for a chassis, all of them, somewhat different to a lot different from each other. Simultaneous with this, I'd be looking at bill of materials. What does it cost to do one chassis versus another? Try to come up with an overall idea of what the cost is, because between the cost and how you can package all your parts to the chassis is going to drive the design of the chassis one way or the other. But again, at this stage, it sounds oddball. I actually haven't designed the chassis yet. What I've designed is chassis concepts, of which one of them will be the basis of what I do, or maybe not at all. I may come up with a 5th chassis design that replaces all these. Continue on the next slide. I do the same thing, and I do what I call a visual bill of materials. And this is, again, I'm a CAD guy, and I appreciate it. Not everyone has access to CAD, 3D CAD, but you could do these with sketches. You could do these just, writing out the components. But because I do a lot of my conceptual design, I do a lot of my brainstorming, 3D CAD, just the way I am, I have this opportunity. I have this luxury of doing things like this. So as an example, that's my seat shell. I define what it is, I define how I'm going to make it, the materials, and the cost, plus the cost for the tooling. Here's a pedal pack from Tilton. That's just a store-bought item. If I use that, that's going to be $600. So over here, this is that aluminum honeycomb, cut and then pleated together. Talks about how much I need, how much I need, and then how much it would cost overall. Same thing on the engine. Here's a Hayabusa motor. What components do I need to add to that motor to do what I want? Well, in this case, I want to add some baffles to the oil pan. I need an airbox filter assembly. I need exhaust. So, but all these things get put together in a bill of materials so I can start getting an idea of how much the car is going to cost. Again, it's very rough at this point in time. And again, it's something you do in parallel with everything else. Like I said, you can do it sequentially, but I find it best to do it parallel, because then you get a really good idea up front where you're going with your car. Next slide. Okay, so you've done all that, and like I said, I call all that brainstorming. All that effort you put into this point in time is just to get you in the zone of what you want on your car. The next step I take is, what's my competition? I want to baseline the design of the competitor, of various competitors out there. So basically, I need to define who the competition is. Who is it? Who's making cars similar to mine? And then go out and evaluate and record the competitor design details. As much information as you can derive from the internet, from whatever, from going into the dealership with a ruler, which I've done in the past, to measure things like how high the seat is off the floor, how much seat room do you have. I literally have done that. I've gone in there and told the guys I want to buy this car, and then I pull out a tape measure and I start tape measuring everything and writing it down, and they look at me and go, well, what are you doing? I go, well, I want to make sure the car fits what I want. I never tell them I really don't want to buy the car. I just tell them, that's what I'm in there for. Ultimately, they get mad at me and kick me out, but by that time I usually got enough data, and if I need more, I go to another dealer. I have no sense of honor or dignity when I need to get information from a car. I've gone in a car show I've gone up and walked onto the display for some competitor show car, and I start taking pictures, and I pull out my ruler and I start measuring things again. And I get kicked out. Sometimes I get kicked out of the whole show. But like I said, I don't care. I do it because I want and need the information. The point of all this is it gives you a sense of what is expected by the customer and what is possible by the manufacturer. And those are two phrases to really understand is, remember, there's lots of other companies out there building cars kind of like what you're doing. And because of that, there's a general confluence, statistical confluence, maybe even a bell curve of what works and doesn't work, or what the customer likes, what the customer doesn't like. The OEMs are smart enough to realize that if they do a design the customer doesn't like and they don't buy it, well, they don't do it again. That's one of the reasons why cars are all very, very similar in general concept, shape, size, particularly on the interior. And that's not because the OEMs are lazy. It's because in the end, everyone's building to the same customer base, and the customer base wants certain things. And that's irrespective of the car that the customer is looking at. So by definition, the design of the car, particularly on the interior, is driven to a common set of parameters. For the manufacturer, it's the same thing. I'm going to have a dashboard that I can bolt in, seats I can drop in, right? That's why things are the way they are. It's because the general nature of the design drives that design to a common set of componentry. Other thing is, when you're looking at somebody else's design, if you're honest with yourself, you can tell what's better or worse. Is your design better in this area, or your design worse in this area? Also highlights what your competitor feels is critical or important. So all this is really important stuff to do. So if you go to the next slide, I'll show you what and how I do that. All right. I have a spreadsheet that right now has, I think, 250 different production cars in it. Different years, different cars. If you look here, this is one that's sort of been whittled down to sort of match the Project Escape car. But if you look across the top, I've got Acura NSX, Ford GT, Lotuses, McLaren F1, something called the Murray Rocket, Ariel Atom, Caterhams, Honda Beat, Lotus Super 7, KTM Expo, and then over on the right, you'll see I've even got some motorcycles, Suzuki Hayabusa and Yamaha R1. And I get as much data as I humanly can on all these vehicles. And as you can see, where yellow is where I'm missing data. So that just highlights I need to find that data somewhere. But I get, everything I can, basic length, width, height, wheelbase, front track, rear track, ground clearance, leg room, weight distribution, corner weights, engine size, engine power, get it all. And like I said, I have a spreadsheet document that has 250 columns for cars of every kind of car you can think of. It's 10, 15 years of gathering this data. And go to the next slide, you'll see some more of it. Performance ratings, 0 to 60, skid pad, brakes, what is the braking distances, what are the brake size, what are the wheel sizes, what are the tire sizes. I try to gather, like I said, as humanly as much possible information as I can, because in the end, this is your competition. Now, my car, the Ford GT, the Acura NSX, the McLaren F1, they're not competition. Like, I'm trying to sell a car for $30,000. A McLaren F1 is, I don't know, $3-4 million now. Ford GT is, 700,000. Acura NSX is 150,000. Even Lotus Exige is, close to $100,000. But that's okay, because they're cars that I perceive as cars that have the sort of performance dynamics feel that I like. So I'm going to include them in my document here. Problem with a document like this is it's really, really hard to glean any trends right? I mean, you're looking at data, but you can't tell if that data is telling you the trend is going one direction or another. So what I do is I take much of this data and I turn it into a graphical form. So if you go to the next slide, there we go. I have on my x-axis all these different cars. On the y-axis, in this case, I have horsepower at a ton, and I range it from least to most. So this gives me an idea of what the competition is in terms of horsepower at a ton. And I want to make this as a kit car component. There's no real trend here other than, more, as you go to the right, you have more horsepower. I mean, you could probably look down here and look at the Lotuses and look at some of the cars and say, well, we're looking at somewhere between 200 and 275 horsepower a ton. That's sort of one range. And then you sort of have another range going at 300 horsepower above. Okay, maybe not get a whole lot of information out of here, but you can glean that for the kind of car we're talking about, somewhere between 200 and 250 horsepower per ton probably puts us in the right zone. So automatically, I kind of know what power I need based on how much my car is going to weigh. That's a design point now that it's sort of got fixed, right? It's a box, but it's still constrained. I've bookended it, which is an important thing to do. If we go to the next slide. Legroom, like what the hell are you doing, Brian? You're measuring legroom on cars? Yeah, absolutely, because that's something that's relevant. And as you can see, I'm missing a lot of data. But here you can start picking out some trends. And the trend is well, it looks like everyone wants to be between, say, 42 and 46 inches, with 44 inches being not a bad average. So you know what? Okay, I want my legroom on my car to be 44 inches plus or minus an inch or two, right? I didn't have to do any design work. I didn't have to do any analysis. I didn't have to lay out any CAD models of a driver and a seat and package everything together. I automatically know I need to be somewhere in this range if I want to have a car that's appropriate. And I know that because that's what every other car out there has. And that's the point of doing this kind of stuff. It saves you from having to, okay, it doesn't save you a lot of work because you have to gain all this data. But once you gain the data, it's amazing what you can pull out of it. If we go to the next slide, ground clearance. Look at that. Real trends here you can see. It's either 4 inches or roughly 5 inches, with some at 4.5. Okay, you know what? I'm going to make my car ground clearance 4.5 inches. I know it works. I know it works because all these other cars are out there. They've been sold. People are driving them, and it works for them. So if it works for them, it's going to work for me. Next slide. This is an interesting one. This one, I don't know why I came up with it. Excuse me here, I need to take a drink. But in the back of my head, I was thinking there had to be a relatively straightforward first order approximation of how to define what I call a vehicle's dynamic characteristics, fundamentally the oversteer, understeer characteristics of the car. Why do certain cars understeer? Why do certain cars oversteer? And is there a very straightforward, simple figure of merit to tell you to what degree a car is going to understeer and oversteer, and be able to be confident that that number is probably going to work for you on your car? So started thinking about it, and I said, well, in the end, all cars, whatever they do through the tires, the 4 tires. So let's look at tires. And the other thing we look at is, what's the other big thing on the car? Well, how much does the car weigh, and how much of the weight is on the front end of the car or rear end of the car? So I from the data I looked at, I said, I'm going to take the front corner weight, like the left front corner, and I'm going to divide it by the tire contact patch area. And people are like, well, how do you get the contact tire patch area? Well, I've got all the tire sizes. I got all that data. So all I do is I say, the tire on this car is this big. All production car tires have pretty similar vertical spring rates. That is, if I were to put a tire on the ground, fill it, to its proper pressure, and I were to put 500 pounds on the tire is going to squish X amount. If the tire squishes half an inch, then it's 1,000 pounds per inch spring rate. Well, okay, I'll just use that as my rough number to start with. And I know how much the front corner weighs, so that tells me how much that tire gets squished. I just draw on my computer a right circular cylinder of the tire diameter. I put a horizontal line on the bottom, and then I take that horizontal line, I move it up by whatever the tire squish is, and I cut that cylinder, and I now have effectively a first order contact patch area of that tire for that car. So I take the front corner weight divided by the contact patch area, and I get these numbers. At this stage, not really sure what those numbers mean, but there they are. Did the same thing on the rear. So if you go to the next slide, did it for the rear of the car. Okay, bunch of numbers, not really sure what difference it has, what it means. But then I did something which I don't really know how my brain came up with it, but I said, let's divide the one by the other. So if we go to the next slide, I came up with what I call, we'll have to have the slide up because I can't remember what I call it. So if we go to the next slide, load rating factor. All right, that's the front corner weight contact divided by the rear corner weight contact patch. And all of a sudden, I'm starting to see some trends here. I see a lot of cars between 0.7 and 0.8, and then a bunch more around 1 to 1.2. Well, what does that mean? Okay, I got these numbers and I've got some trends, but what is it really telling me? Well, go down and you look at the cars that are in the 0.7 to 0.8 range, and you'll see there KTM Expo, Lotus Elise, Lambo Gallardo, Lotus, Porsche, Acura NSX. Well, from a very first order approximation, you could say all of those cars have a propensity to be tail happy. Those cars like to oversteer. Porsche 911s were famous for that. Porsche turbos were famous for being, oversteering cars. Then you go up to the 1 to 1.2 range and look at those cars. McLaren F1, bunch of different Ferrari. Really important to understand. My Ford GT, my Aston Martin, Bugatti Veyron, Corvettes, that kind of stuff. They're all in the 1 to 1.2. Well, all those cars are pretty neutral, balanced cars. And this is in more or less steady state conditions. Obviously, you can take a lot of these cars and you stomp on the gas pedal going through the corner and you're going to be over 10 years ago with me. General steady state conditions, the cars to the left tend to want to oversteer. The cars in the center tend to be neutral. The cars to the right, where the numbers start getting higher, tend to understeer. Wow, look at that. From a very, very basic, very simple analysis where I got the stuff off of Road and Track magazine or whatever else, I now have a way of telling you to what degree your car is going to have what I call basic understeer, oversteer characteristics without doing anything else on the car. I don't need to do any evaluation at all. So that's why I do these things, because oftentimes graphically you can see things that you can't see mathematically. So just giving you guys an example of some of the stuff I do and as part and parcel of my designing a car. So my car, I want to be sort of an oversteering car. So I want my car around the 0.80 load factor rating. So we go to the next slide. Okay, now we can start actual preliminary design. So everything up to this point in time has had nothing to do with the actual preliminary design of the car. Now we can actually start designing the car. And what I want to do here is I want to assemble data of all the main subcomponents of the car. Things like engine, gearbox, brakes, wheels, tires. Even if they're not the ones you're ultimately going to wind up with, I still want those. And if I can get them in 3D CAD, all the best. If not, 2D drawings are acceptable. What I really want, and the reason why I like 3D CAD is because I can do packaging very easily with that. I can also estimate the component mass if I can't find real numbers for that stuff. And I can also estimate the component CG. Sometimes it's just a guess. Sometimes I just look at the model and, okay, it's an engine. Big heavy thing like the cranks down low, but then you got the cylinder heads up top. So you know what? Let's put the CG halfway between the crank center line and where the top of the piston is at top dead center. 85 to 90% of the time, that guess will be within 5%, 10% of what it actually is for the engine if you could actually get that data somewhere. So point here is guessing, you can actually guess pretty well, and it helps you a lot. Next thing is I want a driver model because I got to put humans in there. I got to put a driver and I got to put a passenger. So I need to know what the driver size is and how much they weigh. I typically use, as does the industry, SAE 95% male as their big size person and 50% female as their small size person. For the OEMs, this is really important because this ties into airbag design and crash standards, and it's what NHTSA, when you try to make a car meet all these crash standards, NHTSA, National Highway Traffic Safety Administration, requires you to do all your testing with 95% male and 50% female as your bookends. So, okay, gather all this data together, and now you're ready to actually start putting pen to paper. And the first thing you do is you put in the driver age point, because that's where it all begins. So what's the driver age point? Well, next slide, we'll explain what the driver age point is. Age point is the center of rotation of your hip. It's one of the most important initial design parameters in a car. Basically, all of the interior is built out from that point. And there are many legal guidelines and requirements built around that age point. So you really have to have that, particularly for doing an OEM production car. On race cars, I still start on the age point. Every car I design, that's where I start. I put a point across a point on my computer. That is the age point for the driver. And then I take the driver and locate him there. And then I build the entire car around that age point. So I build it from inside out. That's generally how I do it. The age point will tell you things like, or the age point is used to derive things like seat travel, pedal placement, steering wheel placement, airbags, minimum line of sights, roof height, cowl height, car interior width, clearance to cowl, to cant rails, all that kind of stuff. So let's look at it graphically. So if next slide should be a picture of, there we go. There's your driver, and you can see on the side view, H point. They also call it the SGRP. And then there's a front view showing the H point. And the SAE supplies for just about every driver, male, female possible, these 2D schemes of driver passenger with the H point put in there and other characteristic lines. Headrest point, you can see here, 95th percentile head contour, 95th percentile vision up and down, where your ball of your foot is, where your accelerator heel plane is. All this stuff is included in those SAE documents. So you can grab those and use those to develop your driver model. So, okay, next slide, you'll see how I do with what I do with that and how I do that. Okay, I will in a second. Okay, so now what I do is I'm going to do a very rough packaging of the major components of the car. Start with the driver and H point, and then from that I can put in the seat, steering wheel, steering column, pedal pack, based on the driver location, which is based on driver H point. Then I install the passenger. Then I place sight lines for the driver. Then I add my seat travel based on what I got off my graphs, beforehand for various SAE mannequins. So now I've built up an interior space claim. I know where the driver and passenger is. I know where their heads are. I know where their feet are. I know where their arms are. I know where the steering wheel needs to be. I know where, seats need to be, where the pedal pack is, where the column is, all that kind of stuff. That's all sort of fixed. So now I've also kind of fixed the front bulkhead of the car. If it's a front engine car, that's the front engine bulkhead. Also sort of fixes the rear bulkhead. That can translate a little bit, but generally that sort of fixes the rear bulkhead. So now I've sort of got a space claim for the center of the car. I also know kind of the width of the car now because I know how wide my driver and passenger is. I know how far apart I want to put them. I kind of have a rough idea what a door thickness is. If you don't know, go measure it on your car. Go again, take a tape measure and measure how thick your car is from the inside to the outside, and put that in as a first order approximation of your door thickness. That'll give you a width of your car. So again, you can see it's in some ways it's very, very simple and straightforward. Once you develop that interior space claim, start locating your engine, gearbox, fuel tank, a trunk if you got that. If it's front engine, rear engine, all that kind of stuff, just sort of put it in there. It doesn't really matter at this point in time how super accurate you are, as long as it's visually looking decent, like the engine looks like, okay, it's not running into the firewall, all that kind of stuff, keep it there. Like, you don't have the oil pan hitting the ground, right? I want a ground clearance of 4.5 inches. So I'll locate the bottom of my engine 5 inches up, right? So again, you can see from a lot of that initial information, you can start putting these components in and have a fairly good idea that they're in the right place. Now add some front suspension. Not necessarily suspension arms, but probably just wheels and tires, and add some wheel sweep, which is how much of the wheels steer one way or the other. For a production car, look at 40-45 degrees wheel steer one way or the other. For a race car, 16 to 18 degrees. That's fair enough. Bump and droop of the tire. People want to know, well, what kind of suspension, because there's camber gain and all that. I said, well, don't worry about that now. Just take your tire and move it up or down vertically by a reasonable amount for bump and droop. And, again, it changes for street car and road car. And for street car, it changes whether it's a sports car, a sedan, a pickup truck. So, one of the easy ways to measure that is go out and look at your car. And again, take your tape measure and measure the distance between the top of your tire and the very bottom edge of the fender opening, right? That's probably a reasonable number for what the total bump is. Droop, it's not, it's a little bit more difficult with droop, but on the other hand, droop's not as relevant. Bump's relevant because you don't want, you want to have the tire bumped up in height so that when you put the bodywork on there, the tire doesn't hit the bodywork. In droop, the tire is moving away from the bodywork, so it's, again, not as much an issue. Do the same thing on the rear suspensions. And if you have any body sections, body shape, lay those on the chassis. Whether it fits the chassis or not, don't really worry about. What you got now is a first order layout of the car. And again, it could be a 3D CAD, 2D CAD, can be drawing on graph paper. I don't really care, but you'll have a really nice but rough layout of the car. And that's real important. And the reason why that's real important is for things that maybe you don't initially think of, but it helps you in the actual design of the car. So let's go next slide.
Hey, Brian, I do want to give you a time check. So we have some time for questions at the end.
Oh, so how much more time do I have?
Well, it is 8:20.
And when does this all end? At 9?
8:30.
Oh gosh. You know what's going to happen? This is going to have to be a 3-part series.
Well, we can do that as well.
Because all the really interesting stuff is yet to come. All the really cool stuff and all the really, this is the nuts and bolts of how you design a car is everything that's about to come up.
How much more time do you think that will take?
um, honestly, another 2 hours.
Okay, yeah, I think we will divide this up into a two-part series.
Sorry, folks, but I could have made it a lot shorter, but you know, at the same time, you're not getting as much information. Let me do this real quickly, just so we can sort of um, um, show the next, like, go to the next slide. I'll have you just go real quickly through a couple of them, just so people can see what's coming up. All right, this is just me putting my driver into position relative to other cars. That's all this is. All right, next slide, same thing. Oh, another way. Yep, this is against the Lotus. Keep going. All right, so this is my basic first try packaging. Just showing you what I came up with initially. Nothing really fits perfectly on this thing, but again, I don't care. It just gives a visual indication of the packaging that's required. Same thing for the next slide. Yep, just again, packaging exercise. Now that I've defined what I want and basically everything around the car. Continue on. Side view. Continue on. All right, what we're going to do now is some cool stuff. Go to the next slide. What we do is we create a weight bill of materials. I take every single major component of the car, define it, get a weight, and then I locate it off of that, my basic analysis, a basic CAD model, where the centroid of that particular component is. Then I do things like figure out what the polar moment inertia is, mass centroid axes, all that kind of thing. And in the end, I come up, I do it for all the major parts of the car. And all of a sudden I have weight of the car. I have a load split, percentage in the front of the car, percentage of the rear of the car. I do it, the car empty and the car with driver and fuel. And I have some mass moments of inertia on there, but basically I now know how much the car weighs and what the load split is. Those are really, really critical, because if the car is way, way heavier at this point in time than what you want, you got a problem. And this also tells you if your CG is way off one way or the other relative to what you want. I mean, if the CG came out as 70-30, well, then I've done something wrong, because that's not going to work very well as a race car. So this gives you a real good indication up front of whether you're in the right ballpark with your car. So next slide. General dynamics and performance of the car. We'll go past this because this takes a lot of effort. So just ignore this slide, go down another slide. This is basically all the kinematic analysis on the suspension. Like I said, we'll talk about this later, but keep going down. It's all the information for the kinematics. Keep going down. Then what you do is, okay, go back one, because this is a critical component. If you go back up one slide. All right. I had you guys make a weight estimate spreadsheet, and then a suspension geometry spreadsheet, which is just the XYZ components of the suspension arms, inboard, outboard, NRO bar, all that kind of stuff. I also create a third spreadsheet called load case. This is just basically what's the loads on the car. And I apply loads on the car at the center of gravity of the car. And I apply it in terms of G's. So like under a bump, how many G's does the CG of the car see? That's why the weight estimate spreadsheet is so important, because I'm deriving loads and placing them through the CG of the car, and the CG of the car is defined by the weight estimate spreadsheet. Next slide. So, okay, then I do load cases, and load cases is a real simple spreadsheet. You just have a bunch of different load cases, cornering, bump, acceleration, whether it works on both the front, the overall car, front of the car, rear of the car, and what the G loading is in X, Y, and Z. The numbers I got there are for a race car. They'd be a lot lower for a street car, but you can make them anything you want. These are so as an example, G1, brake corner. I have a lateral acceleration or longitudinal acceleration of -2.5 Gs, lateral acceleration of 1.8, and a vertical of 1. G2 is just going the opposite direction, right? Left and right hand, plus or minus lateral acceleration. So you take those and you apply them on the center of gravity of the car. So go to the next slide. So what happens, okay, this is your geometry spreadsheet. It's just the XYZ components of the suspension. Next slide. So what happens is I know where the tires are located on the car. I know the loads. I know the center of gravity. I know the mass of the car. So I can now tell you for each of these load cases what the wheel load is at the wheel contact point, kilonewtons here. So it's just XYZ loads on the tires in these particular conditions. Next slide. Take these loads and apply them to the upper wishbone, lower wishbone, push rod, track rod. These are internal loads. So the loads going, axially down the wishbones. And again, there's, upper wishbone has forward and aft arm, and what the loads are there. So now I know what the loads are in the suspension. Next slide. I can then take those loads and apply them to things like the rocker, which I'm doing here. Next slide. To, we call it a lollipop. It would be a bushing or monoball end. Next slide. Keep going. To a wishbone mount, suspension mount. Keep going. Keep going. The tubing for the wishbone, right? It's blind ends. So I can design just about every component of the car and do stress analysis and come up with the right size, shape, thickness, material without ever having designed a single one of these pieces. I'm just doing it all mathematically in a spreadsheet. So I've designed the car now effectively structurally off of some very basic initial spreadsheets, 3 spreadsheets. And off those three spreadsheets, plus the analysis spreadsheet is honestly pretty complicated. But between those 4 spreadsheets, I can do anything quicker than any FEA program anywhere on Earth, because I can come up with answers instantly on the most defined, detailed level. Anyway, keep going. Just a summary, you can go past that. All right, you know what? Let's stop here and take questions, because otherwise it's just going to be overwhelming for you guys. Sorry, I apologize for not fitting it all in one, but in the end, maybe it's better. It's two nights. You learn more.
How are you going to take questions?
Just as you go, if you'd like. Bill, would you like to ask your question?
I sure would. Brian, could you give us a little more on your role in the on the Ford GT program, which is a subject I've been so fascinated with, having been to Le Mans once and being a owner and the whole history of that. What?
Yeah, it's actually an interesting situation there. Gosh, around 2014, halfway through there, I was technical director for Multimatic in Canada, and talking with the VP of engineering about potential programs with Ford. And from our perspective, with 2016 being the 50th year anniversary of them winning at Le Mans, they ought to go back to Le Mans. So we went to them, it was an unsolicited sort of, not even a proposal, just, hey guys, what do you think about doing something for 2016 Le Mans? Most of the Ford higher ups looked at us and said, well, what's so special about 2016 Le Mans? And we said, well, it's the 50th anniversary, you shout the car. I'm like,
Yeah.
we did? When did we do that? Half of them didn't even know it. Very little corporate knowledge inside Ford.
Yeah.
So we explained it to them, and they said, "Oh, we'll do a proposal for us." And we said, "Okay, but we're going to need to do it on a brand new car." No, 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 we want it done on the Mustang. And we're like, "You can't use your Mustang as a appropriate race car for Le Mans. It won't work against the competition. It's a good car, but it's not the right car." And they, well, tell us why or why not. So we went through and told them why it didn't work. And the only way you can make the Mustang competitive was to make a $350,000 carbon fibered mid-engine Mustang that inside of you looked an awful lot like a Ferrari 456. Well, that didn't go over very well with Ford, so they said, "Screw you, go away." So we did. Uh, but we lit a candle, internally there, and the candle started growing into a bit more of a fire, and took out a bonfire. And they called us back and said, "Okay, we want to go, but we want to make a new Ford GT." So that's what we're going to do. We're going to design a brand new car, the purpose of which is to win Le Mans. That's the number one purpose. The second purpose is sell enough so they can pay for the program to win Le Mans. So that was the basic guidelines for the program. So okay, Ford gave Multimatic the design responsibility to design and manufacture the car, road car and race car. And I was like I said, I was the technical director then. And so the VP of engineering said, "Okay, it's your program. Make a Ford GT." Okay, I'll make a Ford GT. We worked very, very well with Ford. I got to give Ford lots and lots of credit. Um, Basically, they had their styling guys. They set up a special styling studio in the basement of their big studio in Dearborn. Invoked some emotional working on the Ford GT, and they started doing competitive clay studies of what they wanted for the car. And every time they came up with a clay study, they would send scan data to us. We would turn it into CAD data and look at packaging, and then do CFD to come up with Aero and supply all that information back to them. And then they would take that information and refine their designs to get based on our recommendations of what to do to make the aerodynamics better, make the packaging better. So a lot of iterative collaborative work on that. And after a couple months, they did a design contest where they had all the big wigs from Ford come down, and they whittled it from 4 cars to 3 cars. Then same process again, whittled it to 2 cars. And in the end, we sort of merged those 2 car shapes together to come up with what is now the new Ford GT shape. Early on, the B or C, it was the C, it was version C, had from the very beginning those very unique flying buttresses that attach the engine bay area to the rear fenders. It's all separated there. So that was in very, very early on the program. And that stayed with it because it was such a unique styling concept that everyone liked it. I mean, we all liked console. That's an idea. Ironically enough, it really wasn't that great aerodynamically. It was okay. There was no real negatives to it, but we thought, wow, this will add lots of airflow to the rear wing and to the rear diffuser. And in the end, well, it didn't really add that much. It was a benefit, but not to the degree we had expected. So, surprising, but that's what you learn. We were constrained on engines because the only engine, for 2 reasons. First, Ford really, really wanted to market their EcoBoost technology. So the engine had to be an EcoBoost motor. And the tires and wheels aren't the right size. The V6 twin turbo that they had was the only engine in Ford's inventory that would meet the horsepower and reliability requirements that they required for the street car.
Okay.
They had a Coyote V8 engine that a couple people wanted to put in there, normally aspirated, because everyone, there were people there, well, that's what the original Ford GT had, was a V8. And, nobody's going to want a turbo V6. The problem is the Coyote V8 just couldn't make the power at the reliability levels that Ford needed. and it couldn't meet the emission standards either at those power levels. So that's why it became the Turbo V6. Not, you know, not the most sexy engine in the world, but it certainly works well on the car.
Yeah.
Because Ford wanted to win Le Mans in 2016 with it, they were very open in allowing us to really make the car a race car for the road. It's probably the closest road car, race car out there today, in that there was very, very little compromises made to make it a road car based on the race car. Because we did the race car first, and then coming second was the road car. Not too far behind, but behind. Um, so a lot of it, a lot of the things on the car are very much race car derived. It has a very sophisticated front splitter under tray on the car. Ford's never really done a good job showing that part of the car, but what I did is I looked at a Formula One car, and at the time, Formula One cars had something called zero keel front chassis, front suspension, which is basically the lower A arms came and actually touched each other. So there was no chassis on an F1 car between the lower A arms. There was a little bit. There was, maybe an inch or two of carbon structure there, but that's what the lower wishbone's attached to. Upper ones being shorter, attached to a bit bigger nose section. But I took that, and that's what I did on the Ford GT. So the Ford GT is the only production car on earth that has the zero keel concept, and it comes directly stolen from Formula One cars. It's got a really sophisticated torsion bar suspension, front and rear, with adjustable ride height on it. Again, packaging was really a nightmare in that car. Front suspension, push rod suspension, rocker, and originally we had the damper and spring sort of located where you kind of would expect on a car. The problem is that the production car, because the tires turn 45 degrees, the inside face of the tire would hit the spring and damper, whereas the race car cleared it. Even though the race car tire was wider, because it was only 16-degree steer angle, it cleared it. Well, this was a real problem because there was really no other place to put the damper. The spring we wound up doing as a torsion bar going through the rocker, so I solved the problem with the spring that way, but I still had a damper on the outside of the car, or outside of the chassis, that no matter where we moved it, it just didn't work. So one day I got really frustrated, and I was playing around with it. And again, why I did this, no idea, but sometimes you get lucky. I moved the damper to the inside of the chassis. So it's the damper on that car is right above the driver's foot or the passenger feet. But the damper is actually on the inside of the car. And it's attached through a rod and a lever to the outside of the suspension. Again, the only car on earth ever like that. But again, it was to package the dang thing. Yeah, I mean, I could go through thousands and thousands of hours on, the Ford GT. And that would be, like I said, a good talk on its own. But like I said, the Ford people are not very happy about me doing that. So we could talk about that in private if you wanted one day over dinner or something. We could do that.
Okay, thanks.
Hey, Brian Jai has a question.
Yeah.
I don't mean to get you in trouble, but I think everybody should know the history about Hank the Deuce and how Ford tried to buy Ferrari and how there was this big hoop and holler because they didn't want to put the money into the whole racing development thing because they didn't think they could beat Ferrari. And it's even ironic that you mentioned they wanted you to build a Mustang first because they had Shelby involved with the first GT build. But I do want to know, with all like the reoccurring kind of like stubbornness of Ford to go full force into the whole racing scene, but they always end up somehow excelling when they do. Do you think that was your like your magnum opus, like your favorite project up to date?
No, my favorite project of today That may be the most important project I did, but my favorite project was designing the Williams BMW LMP car that ran in 1999 and 2000. The reason why that is I got a phone call from Patrick Head, who was the technical director for Williams, Grand Prix, saying, Brian, we want to, bring you to England and have you be the chief designer on our Williams BMW Le Mans car. We've never done a Le Mans car before in the history of our company. So you'd be the guy in charge of that. It would be your car, and we would acknowledge it's your car. And so that was, to get a call from Patrick Head is pretty special. Particularly when he says, I want you to, be my chief designer on, what was at the time Williams' biggest and most important car program they've ever done. It was the first program they did with BMW, and they wanted to make sure, everything went right. So, there was a lot of pressure on me, a lot of responsibility on my shoulders, and we, for a variety of reasons, didn't do very well the first year. But we won Le Mans the second year. So that was the first car I did and that won Le Mans overall. So that's why it sort of sits in my heart as being, the car I most like, because it had such relevance and importance to me.
Thank you.
You're welcome.
Someone asked if they could have access to the PowerPoint afterwards. Do you mind if I email it out?
Yeah, send it anybody you want.
They also like to know if you have a LinkedIn or another way to communicate with you.
Yeah, I mean, I'm on LinkedIn, but I got to be honest, I never use it. I'm terrible. I am the worst person on earth with social media. Doesn't mean, I won't use it. Honestly, the best way is email.
Okay, do you want me to include your email when I send this?
Details, but as you can see here, yeah, that works. But yeah, that's me. I mean, the problem is I don't have a Facebook account. I don't have an Instagram account. I don't have a Twitter account. I don't have, like I said, I think I have LinkedIn, but I don't think I've ever used it.
Are you in Atlanta?
I am a Neanderthal, so just deal with it.
Are you in Atlanta?
I'm in Atlanta. I'm in Swanee.
Okay. You got a shop up there?
I have a design office.
Okay.
Just, not very big, but I got that. And then in the back is a small, it's not even a shop, it's just a small garage area I keep my race cars in.
So you've done a lot of work with Panoz too, right?
Oh God, yeah.
Yeah.
Yes.
Okay. What about Jim Downing? You know him?
Know who?
Jim Downing.
Oh yeah, I know Jim real well. I've never done any work with him, but he's an SCCA racer. He's a competitor of mine in SCCA, so we see each other a lot there, and and just in general because it's a good race shop. Like going down there now and then.
What are you driving in SCCA?
I have a Formula Continental, but as of late I've been driving a. It's called a Norma CN. It's a sports prototype. Runs SCCA P1 or P2, just depending on the setup on the car. But it looks like an open cockpit mid 2000 LMP car, kind of like an Audi or Lola or any of those kind of cars. Smaller. It's a 265 horsepower Acura K20 motor with a 6-speed sequential box. I mean, it's 165 mile an hour car at Road Atlanta, 3.5G cornering braking, and very quick lap times in the right hand. It's not in mine because I'm slow, but a proper driver can get that around that car around Road Atlanta in about a 1 minute 20, which is the only cars faster are the LMP cars.
Yeah. Wow.
Do you have any opinion on the Gordon Murray T50?
Yeah, I mean, I actually worked with Gordon before. He interviewed me, and I nearly got hired by him, but didn't work out for a variety of reasons. The only thing I have to question on the car is the sensibility or feasibility for a production street car of having a fan sucking off the ground and dumping that on the back of you. On the racetrack, it's one thing, but on the road, that's another. And for me, it's like, what the hell happens when it rains? You're going to suck a lot of rainwater through that thing, and it's not going to hurt your car, but the guy behind you is going to be blind.
Didn't make Jim very popular, or Jim Hall, I mean.
Yeah, exactly. So I think it's like, okay. The other thing is, I have a very oddball sort of viewpoint on road cars and supercars, hypercars, and all that kind of stuff. It's like, why are you bothering trying to make the ultimate road car that's got 1,000 horsepower, can pull 3 Gs, has all this stuff on there, when 99% of the time you're going to be doing 35 miles an hour in a traffic jam, right? It's like, when do you get it? And even if you're not there, there's no place on any road I know of anywhere on earth where you can use the capabilities of these cars. It just doesn't happen. The only place you can use these capabilities is on a racetrack. Well, the argument I use is, if you're going to be on the racetrack, you might as well be in a race car, because honestly, a properly built race car is so much better at doing what it's designed to do, which is go around a racetrack, than any high-end purpose-built hypercar, Ferrari, Lamborghini, McLaren, any of that kind of stuff. None of those cars. It's staggering. It truly is staggering manufacturing methods. Right? The difference in the performance and the feel of a real race car to even the best sports car out there. My Formula Continental has 145 horsepower, weighs 900, well, with me and a bit more than that, 1,100 plus pounds, but still pretty darn light. 145 horsepower. It's got reasonable tires. But that car, driving on a track like Road Atlanta, will do one, in good hands again, not mine, and 1 minute 27:28 lap time. The top of the line Ferrari 456, 458, 488 car, if they're lucky in the hands of a professional driver, might do a 135. And that's a car with 800 horsepower.
Yeah.
So I'm 5 to 8 seconds a lap quicker. Well, not me, but somebody. In a 145 pound race car to one of these absolutely monstrous supercars. And that's because a race car is designed to do one thing and do one thing only, and that's to race around a closed course. And anything that doesn't help you do that on a race car isn't put on the race car. And as a result, when you're driving it, the feel is infinitely superior to any street car in terms of the feedback you get. If you cut a woman's hair, red, if you take a blonde, a brunette, and a redhead and cut some hair and put it on the track, and I run over it in my race car, I'll tell you which color hair I ran over. It's that sensitive. Anyway, that's
awesome. Well, thank you very. Oh, wait, John Ziegler, you have a question?
Yeah, I was just curious. How did you get started in this business, Brian? And I enjoyed your talk, by the way.
Oh, the court judge said 30 days in jail or go work on a race team. What happened was always been interested in cars, racing, that kind of stuff. And I was living in Connecticut at the time of my high school, and one of my friends was working at a dry cleaner. He knew I liked racing, and he told me one day that one of his customers was the chief instructor for the Skip Barber Racing School, which was at a racetrack, 70, 80 miles north of me. So I made contact with this instructor guy, talked to him. He goes, well, you need to come up to the racetrack one of these days and take a look around. So I did, fell in love with it. He told me about the school. I went home and had a after school job. So when the summer came, I went up there and spent my money and took the driving school. After the driving school was over, they had a race that weekend. I didn't have money to do the race, but I stayed there to watch it. And I was wandering around the pit area, and the mechanics were working on the cars. And one of the mechanics looked at me and saw, the drool coming off my face and said, "Hey, you want to help? You want to, work on the cars?" And of course I said yes. So he threw me a rag and some cleaner and said, "You can start cleaning the bodywork," because nobody wanted to do that. But, for a young kid who was in love with racing, I mean, that's like, how can you get a more perfect job than that? It's like, I'm set for life, that's the way it is. So I started cleaning the bodywork, and Skip Barber, the owner of the series, came by, wandering around. He looked at me and goes, "Weren't you in my class this last week?" I go, yeah. He goes, "Well, are you racing this weekend?" I go, "No, I don't have the money." He goes, "Well, what are you doing cleaning the bodywork on the cars?" And I put it at the mechanic, and I said, he let me do this. I'm really really happy. I was like beaming, and he goes, "Ah, okay." And he walks over, talks to the mechanic, comes back, and he goes, "If somebody's going to do that kind of work for me, they ought to get paid. So do you want a job?" So I said, "Yeah, I'll take a job for the summer." So that's how it started.
Sounds like John Morton with Carol Shelby.
Um, just got lucky, right time, right place. It's amazing how, that sort of scenario works out at times.
Yep.
Very good. Thanks.
Okay, Brian, well, thank you very much for this. And yes, we will set up another talk, I'm guessing, for October.
Yeah, I mean, whatever you want. I apologize. I should have done a better job, but it's all right.
No, it's okay. I think everyone was very excited for the depth of this presentation. So, yes, thank you very much.
You're welcome. You have a good night.
Thank
Thank
you.
you.
You too.
Yep, bye-bye.
Bye.
Bye.